Hello students, in this video I am going to explain one of the very important chapter okay, of science, force and pressure. Okay. So please watch the video till the end. I will explain each and every concepts in this chapter, okay, and you will be able to solve each and every type of questions. Okay. First, let's start, children. Force. What is force? If they ask what is force, it is a push or pull of an object. Okay, is called as what a force. So force comes into play due to the interaction. An interaction of object with another results in the force between the two objects, children. Okay, sign out of force is Newton. Okay, force depend upon the mass of the body, children. Mass of the object. You can see here. Car being pushed by the man. So here is applying the push. That is a force. Okay, a girl pulling a chair. You can see this. Okay, so this girl is applying what a force. Effect of force, children. What force can do? Okay, it can change the state of the rest or motion of the body. Okay, you can see this boy rolling the when a force changes the state of motion of a tire. Okay, makes it into move faster. You can see this boy rolling a tire. Okay, this man you see box at rest moves due to the force. So what force is doing? It is changing the state of the body. Next, you can see here, it can change the size and shape of the body. Okay. So force applied by the hands on the dough changes its shape. You can see here. Okay. In home, our mother while making chapati. Okay. So when she's applying force, the shape and size of the dough is changed. Yes or no? Force changes the size of the rubber band. Okay. You can see if you stretch a rubber band using both hand. Okay. You can see the size, the shape will change. Yes or no? Next concept. There are two types of forces, children: balanced force and unbalanced force. What is balanced force? Okay, if a set of forces acting on a body produces no acceleration in it, then the force is said to be balanced. You can see three persons are there which is applying 300 newtons. Okay, tug of war's game is there, and these three persons also applying 300 newtons. Okay, so force in this direction, left direction and right directions are same, so it is a balanced force. Next, unbalanced force. If a set of forces acting on a body produces non-zero acceleration in it, okay, then this force is said to be unbalanced. You can see there are three persons who is applying, they are applying 400 newtons. Here, three persons applying just 300 newtons. So, force along the left direction is more than the right direction. So, it is a water unbalanced force. Okay. Next, net force. The overall force acting on on an object and after all the forces are combined is called as what a net force. You can see here in this diagram it is clear. You can see these three persons are applying 5 Newton. Okay, and these three persons are applying 5 Newton. Okay, so the net force on an object is 0 here. If the force act on it, the opposite directions are equal, then we can say that net force is what a 0. Okay, the rope will not move since the net force is 0. 5 minus 5, 0, you can see. Next, force can change the state of the motion. Yes, state of the rest. An object is called in the state of rest when it is not moving. Okay, this means a stationary object. Okay, example, a building, electric pole, a ball kept over the ground. Okay, not moving. So these are the state of rest. We can say that in the state of rest, the position of the body do not changes with respect to a reference point. Okay, state of motion means a moving object is called the state of motion. If, for example, a moving car, a moving ball. Okay, so you can see this effect of forces. If they can ask for 2 marks, children. Okay, discuss briefly the effect of forces. So what force can do? A force can speed up a moving object. Force can decrease the speed of the moving object. Yes or no? Next, force can stop a moving object. Okay. Force can change the direction of moving object. Force can move a stationary object. Okay. So these are the effect of forces. They may ask for 2 marks. Next, force can change the shape of the object. Yes. When you apply the force on an inflated balloon using your hand from both sides, The force of pressure changes the shape of the balloon. Your, no, your mom changes the shape of dove into a bread by applying force with the rolling pin. Yes or no? And when the rubber band is stretched in opposite directions, you can see its shape is changed. Yes or no? Next, forces, types and effects. This flowchart you see, children. Force, okay, such as elastic, causes, effects. Okay, so it may affect on the shape, motion, size, and pressure. SI unit, Newton. Okay, such as example of force, friction, cause, work done. Because of force, work is done, children. Okay, yes or no? SI unit, Newton meter, using levers. Okay, work done. Unit, joule. Okay, force such as magnetism. Yes, causes magnets to repel or causes magnet to attract. Okay, such as gravity is also one type of force only, children. Yes or no? So this is a diagram they have just shown. Okay, what force effects. Okay, example cause. Okay, yes or no? Next, types of forces: contact force, non-contact force. Okay, contact force like a muscular force is there and frictional force is there. Non-contact forces: magnetic force, electrostatic force, and gravitational force. Next, types of forces. Okay, same. Contact forces: muscular or applied force, frictional force, normal force. Tension also is a contact force, children. Spring force is also is a contact force. Non-contact forces, once again, you can see magnetic force, electrostatic force, and gravitational force. Okay, let's talk about the muscular force first, contact forces. Force experienced by the bodies when they are in physical contact with each other. Okay, you can see this person pushing the box. So contact forces, muscular force, the force due to the action of muscles. Okay, is called as muscular force. Muscular force is applied only after interaction with the object. Okay, you can see, children. And now, while pulling, example, while pulling a cart, the horse or the ox applies the force of its muscles. Okay, because of this cart moves. Yes or no? Next, contact force, example, frictional force. Force acting opposite to the direction of motion. Suppose this is a surface, children, and box is moving, okay, in this direction, right direction. So frictional force will be acting in the opposite direction, that is left direction. So force of friction is acting over all the moving objects. So force of friction comes into action only after interaction between the two objects. Whenever car is moving, okay, any box is moving, yes or no? So force is there which is acting opposite to the motion, that is called as frictional force, children. You can see here shear reactions force here, this person trying to pull this box, so frictional force will be in what, left direction. Okay, box will be if it is moving in the right direction. Same thing here, see, children. Okay, this car, okay, whenever it is moving in forward direction, and frictional force will be in the left direction. Okay, next, children, non-magnetic force, non-contact force like a magnetic force. Force experienced by the bodies even if they are not in physical contact with each other. Okay, you can see here, sir. Okay, whenever you take a magnet, okay, and take some iron filings, so it will try to attract the iron filings, yes or no? So magnetic force exerted by the magnet is called as magnetic force. Example, a magnet attracts the opposite poles of another magnet, yes. Repels the similar poles of another magnet, yes. Okay, yes or no? So north pole and north pole will get repelled, and north pole and south pole will get attracted, yes or no? Next, non-contact forces, that is electrostatic forces. For another example, force experienced by the charged body on another charged body is called as what, electrostatic force. Okay, you can see that when you rub your comb, okay, with hair, and take some small pieces of paper, what you will observe that it gets attracted because of electrostatic force. Opposite charges attract each other, yes, and same charges repel each other. Plus minus, what they will do, children? Attract. Plus plus repel. Yes or no? So same charges repel each other. Minus minus repel. Repulsion will take place. Okay. Next, non-contact force. Other example is what? Gravitational force. Okay. So attractive force exerted between the two objects. Okay. So example, when anything is released from the height, it falls over the ground because of the gravitational pull of the earth. So earth attracts every object towards its center, children, due to the gravitational force. Okay, children. Now, next concepts is pressure. Okay, what is pressure? Okay, pressure is the force acting on unit area of the surface. It's called as pressure. The force applied on the surface is perpendicular to the surface. Okay, known as what? A thrust. So pressure depends upon two factors, children. One is force, another is area. So pressure is directly proportional to the force, more pressure, and inversely proportional to the area. Less area, okay, more pressure, more area, less pressure. You can see from the definition, pressure is equal to force by area. SI unit is what? Pascal. If you apply 1 Newton, and an area of cross section is 1 meter square, the pressure is what? 1 Pascal. Now see, children, force, more the force applied, more pressure. As I told you, area, greater the surface area on which the pressure is applied, lesser is the pressure. Lesser the surface area, more is the pressure. Okay, you should not consider only those forces which are at perpendicular to the surface on which the pressure is computed. Next up, pressure example in daily life. You can see, children, school bags have wider straps, yes or no? So that area of cross section is more, means pressure will be less. Sharp knives cut better than blunt knife, yes, because area of cross section is less. So pressure exerted will be more. Buildings have wider foundation, yes, because area is more, means pressure exerted on the building will be less. Next, easier to walk on the sand with flat soles rather than shoes with sharp heels. Sharp heel will area of cross is less, na children, so pressure will be more. Okay, if here the flat shoes, what happens? That area of cross section is more, means pressure exerted will be less. So it is easy to move. Bicycle bump with area pressure, you can see here. Okay, next, pressure exerted by the liquid and gases. In liquid and gases, molecules have a space between them and they are randomly moving in all directions and collide with one another. Hence, they exert pressure on the walls of the container, children. Yes, because of the random motion of the molecule of gases, okay, they will exert a pressure on the walls. The liquid exerts equal pressure at the same depth, children. Okay, example, fountains of water coming out of the leaking joints or holes in the pipes you have observed. Okay, pressure exerted by the water at the bottom of the container depend upon the height of its column. Okay, more is the height, more is the pressure. Okay, one more you can see here, children. Balloon gets inflated due to the pressure of a liquid on the walls of the bottle. Okay, next, puncture in the tire as air exerts pressure on the inner wall of the tubes. Okay, these are the examples you can see. Next, atmospheric pressure. The atmospheric pressure extends up to many kilometers of the surface of the earth. Okay, the pressure exerted by the air is known as atmospheric pressure, children. As you know that our earth has a layer of atmosphere, right, which contains many gases like many 78% nitrogen, 21% oxygen, and 1% other gases are there. So these gases particles exert a pressure. Okay, now atmospheric pressure is equal to 101 325 pascals, or we can say it is roughly equal to 10 to the power 5 Pascal. Okay, atmospheric pressure is equal to 1 atm. Atmospheric pressure is measured by a device called as barometer. Important, children, make a note. Atmospheric pressure decreases as the altitude increases. It means if you go up, okay, from the surface of the earth, atmospheric pressure is less. Next, understanding the atmospheric pressure, we get air okay, when we travel by airplane, yes or no? So when the aeroplane lands, air pressure increases, no, which increases the pressure on the eardrum, causing ear pain, yes or no? So I think when you are traveling by flight, you will observe this ear pain. Rubber sucker pressed on a surface sticks to it. So when the sucker is pressed, air between the surface and the sucker moves out. Yes or no? So outside there is atmospheric pressure acting on it, so it sticks to the surface. Okay. Now, when the drinking water with a straw One has to suck the straw. Yes, this causes the pressure in the straw to decrease. The external atmospheric pressure, which is greater than, will then act on the surface of the water in the glass, causing it to rise through the straw. Okay, this guy you can see drinking juice. Pressure in the fluid. Yes, important children. The pressure exerted by the fluid in it is the same in all the direction at a point. Okay, you can see here, children. The pressure exerted is same at all points in the horizontal plane as well as a stationary fluid. Pressure at a particular depth. P is equal to what? H into rho into G. This is the formula for finding the pressure, where H is what? A height of the column of the liquid. Rho is what? Density of the liquid, and G is what? Acceleration due to gravity. So factor affecting the pressure on the area of surface on which the thrust acts. Yes, smaller the area of the surface on which the thrust acts, more is the pressure exerted by the thrust. And larger the surface area on which the thrust acts, lesser is the pressure exerted by the thrust. Yes or no? So you can see here, if the area is more here, so less pressure. Area is less here means high pressure. And there is what? On the magnitude of thrust acting on the thrust, nothing but the force which is perpendicular actually. Okay. So on the magnitude of thrust acting on the surface, greater the thrust on the surface, more is the pressure. This question may be asked for 2 marks. Discuss briefly the factor which affect the pressure. Okay, practical unit of atmospheric pressure, children. 1 atm, I told you, 1.013 into 10 power 5 Pascal. 1 bar is equal to how much? 10 power 6 dyne. Okay, per centimeter square, or 10 power 5 Pascal, or 10 power 5 Newton per meter square. 1 millibar is equal to 10 power minus 3 bar, or 10 power minus 3 into 10 power 6 dyne per centimeter square. 10 power 3 dyne per centimeter. Okay, solve this. 10 power 6 and 10 power minus 3 become 10 power 3, or 10 power 2 Newton per meter square, or 10 power 2 Pascal. 1 torr is equal to how much? 1 millimeter of mercury column, that is equal to 133.3 Pascal. Okay, that's all for this concept, children. If you have good concepts, definitely you can try each and every question. Wish you all the best. Thank you, children.